A block of mass m is resting on a horizontal frictionless table and is attached as shown above to a relaxed spring of spring constant k. A second block of mass 2m and initial speed v0 collides with and sticks to the first block. Develop expressions for the following quantities in terms of m, k, and v0. A bit. V, the speed of the blocks immediately after impact. B, x, the maximum distance the spring is compressed. C, t, the period of the subsequent simple harmonic motion. Here, this is the system. This is a multiple concept question. Obviously, based on momentum and then energy. Okay, collisions, especially collisions and simple harmonic motion. Okay, if you take that one, it will be easy. Here, what is happening? A block of mass 2m is moving with a velocity v0, collides with another block of mass m attached to a spring. The spring is in a relaxed state. That means it is neither stretched nor compressed. Now, after the collision, both the masses stick to each other and then compress the spring. We have to find out the final velocity of the system and also the compression of the spring. And then after compression, the spring mass system vibrates. And these vibrations are simple harmonic in nature. Therefore, we have to find out the time period of the spring mass system. Okay, so these are the three questions. Now let us solve the first bit. The first bit is we have to find out the final velocity of the system. So for that, what we do, we will consider the inelastic collision. The collision is obviously inelastic collision. Whether the collision is elastic or inelastic, the momentum is conserved. So we will consider the momentum and then find out the velocity. So according to the law of conservation of momentum, momentum before collision is equal to momentum after collision. So m1v1 plus m2v2 is equal to m1v1 dash plus m2v2 dash. Okay, where m1, m2 are the masses of the blocks and v1, v2 are the velocities before collision, and then v1 dash and v2 dash are the velocities after collision. Okay. Now here I will write the masses. m1 is equal to 2m and m2 is equal to m, and v1 velocity before collision for the first block v0, and then velocity of the second block is 0 because the second block is at rest. Now, after collision, both the masses stick together and then move with the same velocity. Therefore, after the collision, v1 dash is equal to v2 dash is equal to v. Okay, so we will write the momentum equation. So therefore, 2m v0 plus 0 is equal to 2m plus m times v. Okay, so from this 2m v0 is equal to 3m v. Therefore, v is equal to 2/3 v0. This is the answer for the first bit. That means the velocity of the blocks immediately after impact. Next, we have to find out the maximum compression in the spring. For that, what we do, we will take the energy considerations. So energy of the system is conserved. Therefore, energy before collision is equal to energy after collision. Initially, the system has the kinetic energy. That means only the first block, that means the mass of 2m is moving with a velocity v0, and then the other one is at rest. Therefore, it has no energy at all. And then spring also in a relaxed condition. Therefore, the spring also has no energy at all. Only this block has the energy because it is moving. Therefore, it is the kinetic energy. So kinetic energy is equal to half mv square. And after hitting the second mass, the mass which is at rest, both the masses attach together and then they compress the spring. That means the kinetic energy gets converted into elastic potential energy. Therefore, what is the elastic potential energy? Half k delta x square. Delta x is the compression in the spring. Okay. Now we will write the equation half mv square is equal to half k delta x square. In this, mass is total mass. Total mass is 3m. And then velocity is this velocity, 2/3 v0. And then we have to find out x. That means the compression. So on substituting the terms, respective terms, and then solving, we will get x is equal to square root of 4/3 mv naught square over k. Okay. This is the compression in the spring. Next, because after the compression, the entire system starts vibrating. These vibrations are simple harmonic in nature. Therefore, we have to find out the time period of the oscillations. So the time period of the spring mass system T is equal to 2 pi square root of m by k. Here, mass is 3m and then k is k only. So therefore, T is equal to 2 pi square root of 3m by k is the time period of the spring mass system. Okay. Hope this helps. Thank you. Bye bye.